Good afternoon, students. So in the last class we have seen what is length of perpendicular from origin to the tangent. So now we solved some problems on length of perpendicular from pole to the tangent for the given curves, and also we solved some problems on total equations of the given curves. So find the length of the perpendicular from the pole to the tangent for the curve r square equal to a square cos 2 theta. The curve is given as r square equal to a square cos 2 theta. So now to find out the length of the perpendicular from that pole to the tangent, so it is given by the formula P. Okay, so therefore here first we find the P. To find the P, we differentiate this given curve, okay, with respect to theta. So here there are two methods you can apply. First one, you can take or you can apply logarithm to the given curve both sides and then differentiate, or you can directly differentiate. So taking log on both the sides, which gives log 2 log r equal to log a square plus log cos 2 theta. Now differentiating with respect to theta, 2 by r, differentiation of log r is 1 by r, differentiation of r is dr by d theta. So 2 by r dr by d theta equal to this a is constant, so differentiation of constant is 0 plus differentiation of log cos 2 theta is 1 by cos 2 theta, and then differentiation of cos 2 theta is minus 2 sin 2 theta into 2. Or we say that reversing 2 to get cancelled, and then we reverse this, so which gives r into d theta by dr is equal to this also to be reversed, so it gives minus cos 2 theta by sin 2 theta, which is nothing but minus cos 2 theta. Okay, so then r into d theta by dr is nothing but tan phi, so tan phi is equal to this minus cot 2 theta can be written in terms of tan, which that is tan of pi by 2 plus 2 theta. Both the sides tan and tan will get cancelled, so phi is equal to pi by 2 plus 2 theta. Okay, so when we find, after finding the phi, this is the angle between the radius of and the tangent, then we find P. So P is the length of the perpendicular from the pole to the tangent. So this P is given by the formula P is equal to r sin phi. So P is equal to r sin phi means pi by 2 plus 2 theta. So substitute here, or P is equal to r sin of pi by 2 plus 2 theta is equal to cos 2 theta, or which is equal to P is equal to, this is r, then from the given equation, so that is, this is the given equation, r square equal to a square cos 2 theta. So from this equation cos 2 theta is r square by a square. So we substitute that. So cos 2 theta is r square by a square. So on simplifying we will get r cube is equal to r cube divided by a square. Then cross multiply p, a square is equal to r cube. Okay, so this is the answer for the given problem. Similarly, we find second problem. We know we solve the second problem. So here the problem is given as show that for the curve a square cos 2 theta, a square into a square, show that for the curve r square cos 2 theta is equal to a square. The length of the perpendicular from the pole to the tangent is a into root cos 2 theta. Here the given curve is r square cos 2 theta is equal to a square, or r square is equal to a square by cos 2 theta. Again you apply logarithm or log, taking log on both the sides, then you will get log r square is equal to log a square by cos 2 theta. So now this is of the form log m raised to n, so it is n log m, so 2 log r, which is equal to, again this is log m by n, so log m minus log n, log a square minus log cos 2 theta. Now differentiating with respect to theta. Differentiating with respect to theta, both the sides, so which gives 2 constant. Differentiation of log r 1 by r, again differentiation of r dr by d theta, which is equal to log a square constant 0. Again differentiate this 1 by cos 2 theta into minus sin 2 theta into 2, or 1 by r dr by d theta is equal to sin 2 theta by cos 2 theta. Now reversing this, you get r d theta by dr, which is equal to cos 2 theta by sin 2 theta, again which is cos 2 theta. Now this is nothing but tan phi, which is tan of this cot 2 theta can be written as pi by 2 minus 2 theta. So both sides tan will get cancelled. Phi is equal to pi by 2 minus 2 theta. So now we know that P is equal to r sin phi. P is equal to r sin phi. P is equal to r sin phi. Now substitute the value of phi in this equation, so which is gives r sin of pi by 2 minus 2 theta. So P is equal to r cos 2 theta, because sin of pi by 2 minus 2 theta, it is comes in the second quadrant, and even multiple of odd multiple of 90, sin changes to cos, so r cos 2 theta. Now squaring on the both sides, P square is r square cos square 2 theta. So now this is equal to r square is nothing but a square by cos 2 theta, then cos square 2 theta. From the given equation, r square, that is, this is the given equation, r square cos 2 theta is a square. So cos 2 theta is r square by a square is cos 2 theta. So using that, we write here, then this gives P square is equal to r square cos 2 theta. Okay, or P is equal to, taking square root on both the sides, a into square root of cos 2 theta. So which is the solution of the given problem. Next problem is find the pedal equation of the curve r is equal to a by theta. Again we apply the same thing. R is equal to a by theta. This is the given equation. Differentiate this equation with respect to theta, which gives dr by d theta is equal to minus a by theta square. Now we know that 1 by p square is equal to 1 by r square plus 1 by r raised to 4 dr by d theta whole square, or this is 1 by r square plus 1 by r raised to 4. Now substitute this value of dr by d theta here, so minus a by theta square, or 1 by r square 1 by plus 1 by r raised to 4, on squaring this a square by theta raised to 4. This gives 1 by r square plus a square by r raised to 4 theta raised to 4, or 1 by r square plus this a square get cancelled, and r theta is nothing but a, so replacing that, which gives a square by a raised to 4, or 1 by p square is, taking LCM, a square plus r square by a square r square. So here r raised to r theta is equal to a means here from the given problem, so cross multiply this, r into theta is equal to a. Okay, so r theta is equal to a, we replace that here. So when we replace this, is r raised to 4 theta raised to 4, it is same as r theta whole raised to 4. So replace r theta by a, so it is a raised to 4. So 1 a square get cancelled. Now a square r square is LCM, then simplify this, a square plus r square gives, or reversing this, p square is a square r square by a square plus r square. This is also to be reversed, so a square r square by a square plus r square, and cross multiplication, which gives a square plus r square into p square, which is equal to a square r square. So this is the pedal equations of the given curve r is equal to a by theta. In the same way, we solve another problem. Find the equation of the curve r is equal to a theta. Same again, apply the same technique, differentiate this with respect to theta, dr by d theta is equal to a. Now apply the formula 1 by p square is equal to 1 by r square plus 1 by r raised to 4 dr by d theta whole square. Now substitute this, so 1 by r square plus 1 by r raised to 4 dr by d theta is a, so a square, or 1 by r square plus a square by r raised to 4. Now taking LCM, which gives r raised to 4 is equal to r square plus a square. So taking LCM, r4 is the LCM, here r square is multiplied, So 1 by p square is equal to r square plus a square by r raised to 4. And reversing this, which gives p square is r raised to 4 by r square plus a square. On cross multiplication, p square into a square plus r square is equal to r raised to 4. So this is the pedal equations of the given curve. Next we have another problem. Find the pedal equation of the curve r raised to m is equal to a raised to m cos m theta. Okay, so now this is the given problem right here. R raised to m is equal to a raised to m cos m theta. As I already told, so you can apply log, taking log on both the sides. So which gives log r raised to m. So this can be written as m log r. Okay, and which is log a raised to m plus log cos m theta. Now m log r. So m is constant. Differentiation of log r is 1 by r dr by d theta. Next log a raised to m. A raised to m is constant. So differentiation of log a raised to m is also constant. So it is 0 plus this is log cos m theta. So now on differentiating, this gives 0 plus on differentiating this one 1 by cos m theta. Now again differentiation of cos m theta is minus sin m theta into m. So which is equal to both sides m and m will cancel. So on reversing this, r into d theta by dr is equal to, this is also to be reversed, minus cot m theta. Or this is nothing but tan phi, which is equal to tan of this minus cot m theta can be written as tan of pi by 2 plus m theta. Or both the sides tan will get cancelled. So phi is equal to pi by 2 plus m theta. Now to find the pedal equation, we use the formula p is equal to r sin phi. So there we substitute phi value, that is pi by 2 plus m theta. So p is equal to r sin phi means pi by 2 plus m theta, or p is equal to r cos m theta, because sin of pi by 2 plus m theta, so it is an odd multiple of 90, sin changes to cos, so cos m theta. Pi by 2 plus means it comes in the second quadrant. In second quadrant, sin is positive, so therefore it is cos m theta with positive sign. So p is equal to r cos m theta, which is equal to r. Now from the given problem, cos m theta can be taken as r raised to m by a raised to m, and on cross multiplication it gives a raised to m is equal to r raised to m plus 1. So this is how we find the pedal equation of the given curve. So with this, I conclude this class and continue in the next class. Thank you.